I'd like to now introduce our very own Dr. Nitin Damle, who will be our keynote speaker. Dr. Damle is the immediate past president of the American College of Physicians. While the position has officially ended, he continues to give talks and travel widely. Dr. Damle is an assistant clinical professor of medicine at the Warren Alpert School of Medicine and senior managing partner of the South County Internal Medicine in Wakefield, Rhode Island. His topic today will be climate change, health effects of global climate change.
Just got the lapel mic. I don't know if we can turn down the lights a little bit, or I think this is probably fine. I think they're videoing this, so maybe not. Well, thank you very much for inviting me, Audrey. I think it's visionary, I think, for you to invite me to talk about something that's not traditional medicine in the sense of giving a talk on hypothyroidism or diabetes or something. But I think this topic is so timely and is so important and is affecting all of us now, and for the young folks in the room will affect you more than it will us going into the 21st century. And that's really the health effects of global climate change. And I've given this talk on 5 continents, variations of this, and received varying responses. And actually the most skeptical responses I've received are in some of the US chapters. So it's and I'll show you how telling that is. But so let me start by saying that I have no relationships as far as products or other services, conflicts of interest. And I'll start by calling this global climate change and health the greatest global health opportunity of the 21st century. But I'm going to show you why it's also one of the greatest threats to us. What I like to do is start by talking about the major ideas around climate change and health, give you some context, give you a reason to care about this topic, and then finally show you some benefits that are worth sharing amongst your friends, your colleagues, and maybe perhaps even getting you motivated to give a talk like this. So, I don't know if you recognize this, but this is the famous pale blue dot. This is actually a photograph of the Earth taken from 3.7 billion miles away. When Voyager 1 was launched back in the early 1970s, before it left the solar system, it turned its camera for one more time and took this picture from 3.7 billion miles away of us. And really what I'm here to talk to you about is this small blue dot in our universe. And in 1994, Carl Sagan had this to say about this pale blue dot. He said, "To my mind, there is no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly and compassionately with one another and to preserve and cherish that pale blue dot, the only home we've ever known." And that's Carl Sagan from 1994. So, the United Nations Intergovernmental Panel on Climate Change says this is the greatest global threat of our time. Lancet did a review in November of 2015 and said climate change is the biggest global health threat of the 21st century. The impacts will be felt all around the world, and not just in some distant future, but in our lifetimes and in the lifetimes of our children. And just recently, this year, what they've said also is that anthropogenic, that is human-made climate change threatens to undermine 50 years of gains in public health. So these are the organizations that have statements about human activity and climate change. They range from the American Association for the Advancement of Science to the American Meteorological Society, the Vatican, and Pope Francis, and of course the AMA, AAP, and the American College of Physicians. And I'm really allowed to give this talk under the ACP logo because a couple of years ago we actually came out with a policy paper around climate change and health. So here's the National Climate Assessment 4, which is the latest climate science special report just released just about 3 or 4 months ago. And it says the following. The authors are all leading climate scientists from NOAA, NASA, Department of Energy, and other academic institutions. And what they're saying is that it is extremely likely, that is 99% certainty, that human activities are the dominant cause of global warming. Global temperature has risen by 1.8 degrees in the past 115 years, but most of it since 1993. Global climate will continue to warm. How much will depend primarily on the amount of greenhouse gas emissions globally. And without significant reductions in emissions, the annual average increase could be as high as 9 degrees Fahrenheit or 5 degrees Celsius, which I'll show you is a significant increase in Earth's temperature. So let me just remind you of the greenhouse gas effect. You probably know what this is, but we receive solar radiation. Most of that solar radiation is reflected back into space. But what happens when you have greenhouse gases, which is primarily CO2 and nitrous oxide, is that they interact, the molecules interact with solar radiation and send most of it back down to the Earth's surface, creating further global warming. So there are 4 principles around global climate change. The first one is that the climate is changing and in a pace and in a pattern that's not explainable under natural phenomena. And that's sort of the counter-argument is that this is natural, this is nothing unusual, just let's go about our business as usual. But this is not true. Buildup of CO2 and other gases, methane and nitrous oxide, from the burning of fossil fuels is the main driver of this phenomenon. So it's really us that are creating this problem for the most part. And the harm to humans and the ecosystem has already begun. And this is why I think this topic is so important, because we are already seeing the effects of it. And it's not in some distant future. And finally, there is a chance to stem the changes if aggressive action is taken now. And that's really why we need to spread the word about this. So let me show you who are the largest producers of CO2 emissions worldwide in 2015. And this hasn't changed in the past 3 years. China is number 1 at 28%, the United States at 16%, India at almost 6%, then the Russian Federation and the rest of the world. But it's primarily China, the United States, and India. We are the largest producers of CO2. And this global anthropogenic emissions can be broken up. If we just look at this one pie on this slide, you'll see that CO2 fossil fuel is about 60% of global emissions. There's some from deforestation and biomass decay, about 17%, some from methane, about 14%, and some from nitrous oxide. But the vast majority is from the burning of fossil fuels. So how much? We are exploding 400,000 atomic bombs per day in the world. 400,000 bombs the size of Hiroshima or Nagasaki per day. That's how much CO2 we are putting into the atmosphere. So we don't have much time, because with that, we have consumed about 65% of our total carbon budget if we want to see a 2 degrees Celsius rise over a pre-industrial level. So we only have about 35% of our carbon budget left. And so we need to slow this down, or we're going to see a significant rise in global temperatures that's going to really be very harmful to the Earth. So just how do we consume energy? Well, our energy sources are primarily fossil fuel. We have 15% is coal, 29% is natural gas, and 37% is petroleum. About 10% is renewable energy, and this is the part that we really want to increase, this renewable energy proportion. I'll show you later on how we're going to do that. So let me move on. Let me pivot to what are the indicators of global climate change. There are 4. There's global temperature rise, there's sea level rise, there's ocean acidification, and there's ice melt and loss of glacier mass. The first is global temperature rise. Let me show you a depiction this is from pre-industrial world, say around 1880, 1884. Blue is cool and yellow is hot. So you can see the world is fairly cool into the early part of the 20th century. It's getting a little warmer around World War II. And then post-World War II, it's still relatively cool. In the 1970s is where it starts to heat up. And that's where we are now. I mean, that is a dramatic change just in the past, basically 115 years. So what we have seen is, if we go back to, say, the 1930s, that the number of daily record highs versus the number of daily record lows has flipped. We used to see a lot of record lows in the 1930s to the 1970s and 80s. But now we hardly ever see any record lows. We only see record highs, especially since the year 2000. So if we talk about how much of this is from human factors versus natural factors, well, this is what it would be if it was just purely natural factors in terms of global temperature change. But this is actually what we're seeing from natural and human factors. This is what we're observing. And what is the projected global temperature rise in degrees Fahrenheit? I think there are predictions anywhere from 2 degrees Fahrenheit, which would be unrealistic, to more like around 6 to 8 degrees Fahrenheit if we do nothing at all before the end of this century. So people might say, well, what's the big deal? 3 to 4 degrees of Celsius or 5 to 6 degrees Fahrenheit increase in the Earth's global temperature. It's not going to really affect much of anything. Well, let me show you what's happened over the past 20,000 years. So if we go back to the end of the last ice age, 20,000 years ago, there was actually a temperature drop of approximately 4 to 5 degrees Celsius that created the ice age and led to the extinction of the dinosaurs. Then there was a rise in the temperature about 10,000 years ago, just about when agriculture emerged. And then the temperature has remained flat pretty much since that time, through medieval times. There was a little ice age in Europe between the 15th and 18th centuries where the temperature dropped 0.5 degrees Celsius. Then it rose again, and it's been pretty flat up until now. And the problem is right here. Between now and 100 years from now, the 21st century, we're going to see this very rapid rise of 3 to 4 to 5 degrees Celsius. So you can see that the magnitude of change here is very similar to the magnitude of change here that produced the first ice age. So this is a significant rise in temperature and not to be taken lightly. So let me move on to ice melts and glaciers, and it's much more than just a polar bear on an iceberg. This is a depiction of what the Arctic cap looked like about 13 years ago, and this is what it looks like now. So we're losing about 500 billion tons of ice per year over the past 13 years. So it's fairly dramatic, and it's happening not just in the Arctic and the Antarctic, but also in other parts of the world. This is Los Glaciers National Park in Argentina, where the glaciers are melting. This is the Mendenhall Glacier in Alaska. This photograph was taken in 1894 by Ansel Adams. This photograph was taken by myself in 2015. Here's the Muir Glacier, just as near as 1941 versus to what it is in 2004. So what that means is that projected Arctic sea ice decline will be so dramatic going forward in the 21st century that down here by the end of the century, during the summer months, we expect that there'll be no ice in the North or the South Poles, in the Arctic or the Antarctic in the summer months. So let me move to sea level rise. And these may seem a little bit exaggerated or draconian, but I submit that they're probably not too far from the truth if we don't do something soon. This might be Miami in the near future. This is actually from a movie called The Day After Tomorrow, and this is actually a tsunami that hit New York City, and you can, but maybe not far away. Here's the historical and projected global mean sea level rise. It's been pretty steady for most of the past 2,000 years, but look what's happened here. Just within the past few decades, we've seen a dramatic rise in the sea level. And the projections are out to the end of the century that there'll be a rise of about 4 to 5 to 6 to 8 feet of sea level rise, which is very significant. And if you look at what it will do to different parts of the United States, the most vulnerable parts are really us up here to some degree, but down here in the southern Atlantic states, Virginia Beach area, Charlestown, all the way down to Miami, which will be mostly underwater, all the way up into New Orleans, which is already underwater, and it will be at further risk of problems with flooding. This is Jamestown. Actually, I live right there. And this is our lighthouse. If there was a 4-foot, or actually more like a 6-foot sea level rise in Narragansett Bay, most of this island would be underwater. Most of this island would be underwater. So as the sea levels rises, the oceans absorb more heat, they absorb more CO2, and when you absorb more CO2 into the water, what happens, if you remember, your pH drops. So the pH is dropping as the CO2 levels are rising. And that's important because pH is really important to the ecology of sea life. So this is actually a pteropod. This is a pteropod from the South Pacific where the ocean is not very acidic. It's actually fairly reasonable. And this is from the North Pacific where it's all shriveled up and died. And the significance of this is that pteropods are a food source. They're a food source for everything in this ocean from krill to whales. So if they have no food source, then obviously they're also at risk. Here's the Great Barrier Reef in Australia. And it's being bleached and is dying at 400 miles per 18 months. 400 miles every 18 months of this is destroyed. The coral is getting destroyed. The ecology is being affected. And this is all bleached coral. That's pretty much all you see now. And finally, 50% extinction of plants and animals by the year 2100, and a mass migration at 18 feet per day to the poles. 50% extinction of plant and animals before 2100. That has never been seen before. So let me move to the major events, and there are 5. There's forest fires, there's drought, there's floods, there's heat waves, and there's extremes of weather. And we've seen a 46% increase in all of the above just in the past 35, 40 years. So this is a world map of the number of drought, heat, and fire events all over the world just in 2016, just in 1 year. And if we look at the United States, what we're primarily looking at is in our area a lot of extreme precipitation, some flooding. Down here in the southeast, we're looking at hurricanes, more intense hurricanes and more frequent hurricanes. Here we're looking at sea level rise. Here we're looking at rising temperatures. The southwest, we're looking at drought conditions and heat waves. And the northwest, we're looking at wildfires, which are already, if you remember, already beginning. So let me move to wildfires. We burned 8 million acres in the year 2017 from wildfires. 8 million acres in 1 year. And the problem is not only that the number of wildfires has increased substantially, gone from less than 1,000 back in 1960 to over 3,000 now. And the number of acres that are burned per wildfire has increased. So now we are at 8 million acres per wildfire. So it's not just the number, but it's the amount of acreage that's being burned. These are just examples. This is outside of Portland, Oregon, where there was a wildfire this year. This is in Yosemite, and this is actually in Glacier National Park, where they're burning. And this is in Yosemite, a camp store that's also in the foreground of a burning forest. Here's the San Bernardino fire, which cost $7 billion and caused 41 deaths. What's interesting about these 41 deaths is that almost all these people were elderly. And the reason they died is because they had no resources to leave the area before the fire hit. They couldn't get out. So let me move to flooding and storm surge. Well, it's flooding and storm surge is not just a phenomenon for us. It's also true in Europe, in Africa, in Asia, and Oceania. Globally, 1 billion people lack access to safe drinking water. That's only going to get made worse by flooding and storm surge. 2.5 billion people lack access to adequate sanitation. Again, will get worse. And 5 million people, primarily children, die from water-related diseases every year. And this will clearly get much worse as we see more flooding and more storm surges. We see this in the United States. This is in Sorrento, Louisiana, where water is in floodplains that they're not planning on. This is in Norfolk, Virginia, where you can't build a house without a raised foundation because the water level is so high. This is Highway 1 in Port Fortune in Louisiana. This Highway 1 is significant because it carries 18% of the nation's oil production. Just this one highway. 90% of U.S. offshore oil and gas production is in this area right here of the country. And so this would all be underwater in Louisiana by the end of this century. In Rhode Island, rising waters, we're pretty vulnerable. Westerly, 12.8%, Charlestown, 20%, Narragansett, 18%, all the way up here, South Kingstown. Areas that are somewhat protected are probably like Cranston, Providence, East Providence. Barrington, very susceptible. Warren, very susceptible. Of course, the east side of the bay also very susceptible to rising sea level rises. So far I've gotten you pretty depressed about the world, but I have to admit that I'm not a climate scientist. And so I've told you all I know about climate science. But I think we know a lot more about health and the threat of the 21st century being that our health is affected by global climate change. And that's what I'm going to pivot to next. So what I've talked to you about is really the inside of this wheel, rising temperatures, extremes in weather, weather events. But now I'm going to talk about the 7 different human health effects. The first one is heat waves. 130 million people were vulnerable this past year to heat waves, and by 2040, it's going to be 1 billion people that are going to be susceptible to heat waves, 120 degrees or even higher. Heat-related effects, as you know, there are 3 clinical presentations. There's mild symptoms just of rash and fatigue. There's heat exhaustion, which is thirst, weakness, dizziness, cramps, headache, nausea, vomiting, diaphoresis, or tachycardia. And then there's heat stroke, which is confusion, syncope, coma, dry or moist skin, and a core temperature of greater than 104 degrees. Obviously, here you would need to be admitted from the ER. So these are the projected change in the number of days over 95 degrees. And you can see here that for us, it's going to be somewhere around 10 to 20 days over 95 degrees. Down here in the south, it's going to be more like around 40 to 50 days of the year at greater than 95 degrees. And 95 degrees is significant. This study was actually done here in Rhode Island. And what it shows is that for a day that was at 95 degrees, all-cause ED visits went up by 6.6% for the following 7 days. Heat-related ED visits went up by 90% over the following 7 days. Oops. And the threat and deaths increased by 5.8% on the same day for every day that there was a temperature of 95 degrees or higher. So this is really a kind of a tipping point and is very significant for us. If you look at the number of heat-related deaths, you might say that it's mostly all males, but it's mostly males until you reach about 65, and then it's about an equal male-to-female ratio. So why is this significant? Well, it's mostly our patients that really are groups that are increased risk. The elderly, because they sweat less, they have less of a thirst drive, they have cardiopulmonary renal conditions, they are on multiple medications, they have poor thermal regulation. Children, because again, they have thermoregulatory issues. Sports enthusiasts, laborers, homeless because they can't recognize the problem and they don't have resources to cope. Poverty and lack of air conditioning, urban settings with pavement and lack of trees. Any heat wave, there's usually about a 15 to 20% difference between the temperature in the city versus in suburbia. And of course, people with chronic conditions such as COPD and congestive heart failure. So if we look at projected extremes in temperature and mortality from where we are now, we're at about 2 to 3 deaths per 100,000 people in the United States and most of the country. Mid-century, we're going to be at around 8, 9, or 10. But by the end of the century, by 2100, we're going to be at around 15 to 18 deaths per 100,000 people. Pretty dramatic shift from even where we are now. And let me just back that up with some heat waves that we've experienced. We had 7,400 annual deaths in the United States in that 10-year period. Remember, we saw 15,000 deaths in France in just 1 year. We saw 70,000 excessive deaths in Europe in 2009. And if you remember, we saw 15,000 deaths in Russia in 2010. And so what can we expect? By 2081, Chicago will experience 2,000 deaths per year. In 200 U.S. cities, there'll be 11,000 deaths per year by 2030. And there'll be 30,000 deaths per year in the United States by the year 2100, just from heat waves. So what can we do? Well, we can do something. There is some things we can do to prevent this morbidity and mortality. And part of that is communication by clinical teams to reach vulnerable populations, public health warning systems for impending heat waves, temporary housing for vulnerable populations, timely education about the risk of heat illness, and community outreach teams to organize public health authorities. And what's remarkable is that a lot of this work has been done in Rhode Island. And we are really ahead of the curve. The Department of Health is very active in this area, and a lot of this has been set up. So let me move to respiratory effects. This is Moscow in 2010. This is New Delhi this past year. This is Los Angeles, and this is Paris during the Climate Accord meeting. So particulate matter and ozone are the primary problems as far as respiratory effects are concerned. Then the primary source is, again, automobiles, power plants, and forest fires. 43 million people in the United States and 92% of the world live in excess of the WHO limit on particulate matter. And in 2015, this is the same for 16 and 17, there were 7 million deaths attributable to air pollution. Ozone levels are also increasing to 60 parts per billion by 2030, and I'll show you in a minute why that's important. And there's even some evidence of an increased risk for neurodegenerative diseases and Parkinson's and dementia. So the reason that ozone is important is not because it's a toxin in itself, but what it does is it tends to tighten smooth muscle, and it also leads to increased air trapping in our alveoli. And as a result of this, it creates more vulnerability to the effects of small particles and allergens. So as ozone level rises, we're more vulnerable to all of these particulate matters. And if you look at ground level ozone, we're probably less susceptible here on the East Coast than they are over here in the Southwest and in the South. So moving to allergies and asthma, we know that 55% of the US and European populations test positive for allergens, and 34 million people have asthma. We know that there's an increased length in the pollen season, and I think most of you have probably seen that in your offices. There's an increased CO2 production from the growth of allergen-producing weeds, grasses, trees, and fungus. And the rain and floods leads to more increased mold and fungal growth. So if we look at the length of the aeroallergen production season, if we take the baseline, the season length is about 177 days from about May 3rd to October 25, which is the first freeze. By the end of the century, or close to it, by 2084, the tree bloom will start about 2 weeks earlier on April 12th, and the first freeze won't be until November 12th. Our season length will go from 177 to 214 days. That's going to affect a lot of people who have allergy and asthma. Right now, allergies, 11 million office visits per year, $11.2 billion per year to treat. Asthma and COPD, 2 million ED visits per year, 500,000 hospitalizations, 3,600 deaths, at a cost of $56 billion per year. So it's an economic price to be paid too. Infectious disease. This is deaths from vector-borne diseases in the world. And you might say that this is more of a problem for the rest of the world, sub-Saharan Africa, India, Latin America, but not really. Because of what is going on, the vector ecology is changing, and we are going to be affected by vectors. And it's primarily driven by temperature rise. It accelerates the pathogen development. It affects their biology and physiology. They're able to complete their cycle at higher altitudes and latitudes. Global wind patterns changes the migration of the vectors all around the world. Precipitation changes the length of the season that the vectors can survive. and changes in relative humidity results in an effect on their lifespan, but also on their genetic composition. They become much more resistant. And we know one vector-borne disease from last year is Zika, and you can see how it affected most of the United States from the Aedes aegypti mosquito. And we had a number of cases, I think 25 or 30 cases right here in Rhode Island from Zika virus. So the WHO predicts that, or states that in North American European region, mosquito will carry 58 million cases of dengue, resulting in 10,000 deaths in just 2013 and many more now. Chikungunya, malaria, West Nile fever, and Zika will be the primary mosquito vector-borne diseases that we will be seeing. Sandfly-borne diseases we'll see is leishmaniasis. I've never seen a case. I don't know if anybody here has, but I think we will likely see more of this. And of course, we've seen a lot of this. The incidence of Lyme, Anaplasma, and Babesia is rising significantly. We're all very familiar with that. Here's the annual cases of Lyme disease in the United States. Back in the mid-'80s, early '80s, when it was first discovered, it was around 50,000, 55,000 cases. We now have about 300,000 cases in the US. If we look at Rhode Island, the rate of Lyme disease is primarily localized to Washington County, where I practice, Newport County, Kent County, and some in Bristol. Providence is somewhat immune, but we certainly are at very increased risk. I think all of you have probably seen a number of cases of Lyme disease, Babesia, and Anaplasma through the years. And finally, the last infectious disease that we're going to start to see, and we haven't seen since about the late 1800s, is the resurgence of malaria. Malaria is already present in much of Europe during the summer months. As we know, it's endemic in areas like India and Southeast Asia and Sub-Saharan Africa, and to some degree Latin America. But the amount of risk that we're going to see is going to be significantly increased, especially here in the Northeast. So before the mid-century, you will likely start to see malaria that is not coming from overseas. Waterborne diseases. So heavy downpours and increasing exposure really creates problems because it affects rivers and it affects streams, it affects homes, it floods homes and businesses. It really affects stormwater systems. It affects the contamination of different chemical plants and sewage, and bacteria and virus and parasites get into all kinds of areas, from farms all the way to factories and even to our table, as I'll show you in a minute. But let me show you an association between precipitation and waterborne disease outbreaks. This was in Ontario in approximately 2005. And this was a period of a large amount of rainfall in about a 3-day period of time. There was about a 3 to 4 day incubation period here. And then there was a sudden rise in the number of E. coli, toxigenic E. coli cases. Number of cases rose to about 40 or 50 within the next 3 to 4 days. I think there were about 6 deaths from this also. So other bacterial contamination, including toxigenic E. coli, Campylobacter, you'll see an increase in that. Salmonella, Leptospira, which is in the urine of infected animals and rodents. And as I said, because of floodwaters, you'll see more of that in your soil, in your water supplies. And higher temperatures will lead to higher rates of production of all of these bacteria. Vibrio is strongly influenced by climate. Vibrio cholera, we know there's about 3 to 5 million cases in the world with about 120,000 deaths yearly, mostly children. But we'll start to see more of that in this part of the world. In particular, the Vibrio parahemolytica strain is already a concern. Maryland shellfish and Alaskan oysters have really been a public health problem for a long time. And this is only going to get worse. We may even see a resurgence of Legionella because of warm water and the potential to colonize water systems in buildings. Parasitic infections, Cryptosporidium, there's about 2,000 to 3,000 cases per year annually, and it's primarily through livestock waste and contaminated water again. Cryptosporidium oocytes are detected in 65 to 97% of surface water tested in the United States. And the problem is that chlorination is not effective for Cryptosporidium. 1993, there was an outbreak in Milwaukee that resulted in 400,000 cases, 100 deaths. In 97, there were 2,500 cases in 45 states. So it's spreading. Giardia lamblia is spreading. The cysts are found, again, on raw surface water in animal and human species. And about 40% of filtered, that's filtered drinking water, has either Giardia or Cryptosporidium in it. Cyclospora has already affected, there were some salad bar and cilantros in Texas and Nebraska and Indiana that were affected by Cyclospora. And finally, viruses. Viruses are heat resistant. They're likely to survive sewer treatment processes. And the primary ones are hepatitis A, norovirus, and Norwalk virus. Food security. Food security is really at threat because right from farm to table, temperature rise causes to increase spoilage of food. It creates problems as far as transportation is concerned, and it creates problems as far as nutritional value of food itself is concerned. So if we just look at how much CO2 it takes to produce the food that we eat, look at what it takes to produce lamb and goat and beef versus what it takes to produce dairy, milk, poultry, eggs, nuts, soy, fish, rice, beans. The impact on greenhouse gas emissions is fairly significant. And we shouldn't be eating this much of this anyways. We should be moving more towards this type of a diet as it is, and here's another reason to do that: climate change. So if we look at atmospheric CO2 concentration in parts per million versus protein content in flour, and we are about here right now, as CO2 concentration increases, the protein content of food decreases. So you not only have less food, but you also have less nutritious food, and it's true for minerals also. So in fact, increased crop losses from diseases, as I mentioned, such as fungi, bacteria, and viruses, decrease nutrient content, and global climate change will decrease food production by 2% per year in the face of a 14% per year increase in demand. So there's going to be a 16% shift, or a 16% deficit. 6% decline in global wheat yields, 10% decline in rice for every 1 degree Celsius temperature rise. And reduced water supplies from droughts will affect 100 million people in water shortage areas. Mental and emotional effects, my last health effect. Yeah. So far I've just talked about medical and physical effects, but mental health effects are significant. Stress, anxiety, depression, strains on social relationships, substance abuse, community health, even interpersonal aggression, violence, increased social instability. All of this has been seen around the world. One example here in the United States is the effects from Hurricane Katrina. 49% of people developed an anxiety or mood disorder that were in Katrina. 1 in 6 developed a post-traumatic stress disorder. So this is not something to be taken lightly. Mass migration. Over 1 billion people will need to migrate in the 21st century purely because of rising sea levels. And that'll be not just all over the world, but also in the United States. We've already seen in 2012, extreme weather drove 32 million people from their homes, and many in the United States, and this will only get worse. In fact, and this is, I think, telling, if we look at the predictions as of 2016 for the next 18 months, why will people move? Large-scale involuntary migration from weather. Not state collapse, not interstate conflict, not unemployment, not because of failure of national governance. If you go out 10 years, water crisis, failure to mitigate against climate change, extreme weather events, food crises will all outpace profound social instability. And who will be vulnerable the most? Well, these are, again, our patients. It'll be the aging population, the asthmatics, obesity, chronic respiratory diseases, people with diabetes, and, of course, people who are poor. So the WHO predicts that there'll be 250,000 deaths per year from 2030 to 2050, primarily from the diseases that I've just talked to you about: malaria, dengue, diarrheal disease, heat stress, undernutrition, and the heaviest burden will be borne by children, women, older people, the poor, individuals of color, disability, diabetics, obesity, respiratory diseases. So if that doesn't get you depressed, let me give you some hope, and that's why I'm going to now, in the remaining time, talk to you about the biggest health opportunity of the 21st century, and this is where I think all of us can play a role. This is the Paris Accord in 2015. President Obama, President Hollande, Bill Gates, and what they agreed to was a 1.5 degree rise in Celsius temperatures over pre-industrial age going forward, a global temperature rise. They also agreed that parties should promote their obligations on the right to health when addressing global climate change. So even in this international political community, they recognize that really health is at stake here. And of course, there were other things that they did, including setting up sustainable development goals and so on. But they had three principles, three mitigation principles. Number one is that global efforts to reduce anthropogenic greenhouse gas emissions need to be in place. The developed countries need to take a leading role in developing, implementing, and monitoring the success and mitigation measures. So enough finger pointing, enough blame. Everybody really needs to step up and do this. Health co-benefits are an integral part of global climate change discussion. So again, we are at the table, and that's why we need to take advantage of this. Strategies, well, they're somewhat obvious. Expanded use of low carbon or carbon neutral energy, improve carbon sinks by decreasing deforestation, increase fuel efficiency standards, increase efficiency standards for buildings, and create financial incentives for proper land management. So where are we? Well, this is a map of countries with climate change adoption plans. China is way ahead of us. Some countries in sub-Saharan Africa have plans. Latin America has plans. We have relatively few plans. And we're the most industrialized country in the world. But there is hope and there is movement. And the healthcare industry, again, I think can take the lead on this. We're one of the largest consumers of energy. We consume more energy than anybody except for the food industry. We spend about $9 billion annually on energy costs, and in the hospitals around the United States produce about 2.3 million tons of garbage per year. So there are lots of things, again, they seem fairly clear that we can do. Energy efficient lighting, recycle and use, purchase recycled products, electric car charge stations, clean energy sources such as wind and solar, environmentally sustainable building materials, reduce fleet emissions, waste conservation and disposal, and finally green energy, green building design. And let me give you a couple of examples. This is the Boston Green Ribbon Commission Healthcare Working Group. And this was 22 Boston area hospitals that agreed to participate to drop by 25% their greenhouse gas emissions by 2020, 80% by 2050. What's amazing is that Mass General has dropped its greenhouse gas emissions by 35% as of 2014. Boston Medical is on track for 45% cut within the next 2 years, and Brigham and Women's will reach 35% within the next 2 years. So there is movement, and I think we can all be part of that movement at a tremendous cost savings also. This is a private practice group in Washington State, and they have really put together a building that uses ground level vegetation and green roofs. They have specialized sensors for activating cold water for cooling medical equipment. They use very efficient steam generators. They recycle and they construct out of recycled material. And they have car charging stations and bike racks on site. So there are some things you can do personally. You can commute less. You can use electric cars. You can walk and bike more. You can eat healthy foods, if you remember the chart that I showed you earlier. You can limit your air travel, and you can not use water bottles. And the water bottles is interesting because it's not just the amount of energy it takes to get the water but to go into the bottle, but it's the amount of CO2 it takes to actually make that bottle itself, that plastic that you have to use to get the water in there. And there's no reason, really, to use water bottles. California. Always ahead of the curve. California, this is Jerry Brown signing legislation that says that California will be 50% renewable by the year 2030. That's just basically about 10 years from now. 50% renewable. These are, in San Diego, these are electric police cars. This is a wind farm outside of San Diego. And this is the sale of electric cars around the world. And you can see that it's really skyrocketed here in the past couple of years. And in fact, as Sweden is taking the lead on this, and Volvo has already said by 2020 that they will not be making a combustible engine anymore. They'll just be purely electric cars. Here's Google headquarters in Mountain View, California, and their data center in Pryor, Oklahoma. They are 100% renewable. They use more energy here at Google headquarters in Mountain View than the city of San Francisco, and they're 100% renewable. This is China. This is Shanghai in 2017. This is why they have an interest, and they're taking the lead. Solar panel industry in China is a $3 billion per year industry, and it employs 3 million people in that industry. And what's interesting is they make these solar panels, and they actually make these wave-proof solar panels that they actually float out into the water. So they are really ahead of the curve on this. And Saudi Arabia, Saudi Aramco is one of the largest oil companies in the world, and they are building solar farms all over the desert. So they are moving ahead. Here we have wind farm. We have a wind farm off of Block Island, as you know. Right now, there are about 50,000 turbines in the United States, all land-based. They provide about 5% of the energy that we use. But we're hoping that these sort of wind farms will kind of dot the landscape of the East Coast because there is so much wind that we can take advantage of. And we know that the price of wind and solar has really come down. It's come down from around $1,300 per kilowatt hour US dollars to approximately $100 per kilowatt hour just over the past 15 years. The price of oil kind of is up and down. It doesn't really change that much. And if we look at the photovoltaic cell, which you need in order to have electric cars, $76 per watt, 30 cents per watt. Wind cost, 55 cents per kilowatt hour, now down to 2.5 cents per kilowatt hour, 2.5 cents per kilowatt hour. So 22-time price decline. And global energy consumption, it's not only us, but all over the world. The amount of renewable energy that's being used is really skyrocketing again, just primarily here in the 21st century. So what I'm asking for you to do really is to divest from this and invest in this. And you can do this. Public-private partnerships in a green economy is a very viable alternative. The United Nations reports that it's going to take about $90 trillion over 15 years to make this transition. The world GDP is $73 trillion for 1 year, just for 2015. So we're not talking necessarily about a lot of money to get this done. And what they've also said is that they want to set up these principles and guidelines on investment, credibility, disclosure, and transparency. They want to help create bonds and incentive programs, create emissions taxes and trade credits. And China has gone ahead and put together a green bond market, which is now about 40% of the global green bond market that there is. And there's also multinational trust funds for solar energy that are being developed all over the world. So there is a way to move forward in this green economy. So even with the repeal of the Paris Agreement by our current administration and the repeal of the Clean Power Plan by our current administration, economic forces, I think, will dictate the movement towards clean energy. The tax incentives and the tax credits are extended to 2021, so we are safe, hopefully, through the next election. Improved battery, wind, and solar technology. And social investing is significant. 69% of Fortune 500 companies are requesting low-carbon products, 69%, and are investing in non-fossil fuel industries. They're moving away from those. The Trump administration, if you remember, banned 3 EPA scientists from discussing climate change here in Narragansett. This happened this past year. They wrote this 500-page report that was funded by the EPA, and then they said that they wouldn't allow us to talk about it. The peer review process was under attack, and the voices were not able to be heard. Climate change has been removed from the EPA website. State plans for climate change are removed also from the EPA website. This is something that we really need to reverse. We need to fight this. And this is something, again, that you as physicians and medical students really can get involved in. Resilient Rhode Island is an act that was put into place under Governor Raimondo's administration. And again, Rhode Island is a little bit ahead of the curve. It established an executive climate change coordinating council. It set up some specific greenhouse gas emission targets. It established an advisory board. It incorporated climate change impact on the powers and duties of all state agencies. And it set goals for 10% within the next couple of years of reduction of emissions of greenhouse gases over 1990 levels, 45% by 2035, and 80% by 2050. So that's a little less ambitious than California, which said 2030. But I think that's still, I think, very positive move here in Rhode Island. And again, this is where you can come in, you're an advocate, you're respected, you're part of the community. You really should be out there talking about this type of issue to your town councils, to your mayors, to your community centers, to your schools. Anybody who's willing to listen, you should be talking to them about it. I'm happy to share these slides with you if you'd like. But I think the important thing is to get the word out. I've given probably maybe 25 talks on this already between the national chapters and internationally. And it should probably be included in the medical school curriculum going forward. So never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has. And that's a quote from Margaret Mead. So if you don't believe anything I've said so far, I'll leave you with this question. Which world would you like to live in? Do you want to live in this world of mass migration, flooding, pollution, drought, heat waves, poverty, starvation? Or do you want to live in this world of biking and hiking and green buildings and healthy foods and electric cars and solar panels and wind energy? And really the choice is ours. I think really what we have as global climate change is not just a health imperative, it's an economic imperative, it's a political imperative, and it's a moral imperative. And I think there'll be opposing forces that will fight this all the way, and they'll be saying no, no, no all along. But I think what we're talking about is, as Wallace Stevens says, I don't know if you know who Wallace Stevens is, a great poet, but he said, after the final no comes a yes, and on that yes, the fate of the world exists. And this is what we're talking about, taken from Apollo 8 of the Earth. So I'll stop there. Thank you very much.
Thank you very much.